All right, now we're going to generalize and do double integrals over any region. In the previous section, we just did it over rectangles. And let's try a couple cases. This is case one. We could get something like this, where we have, here's a function, it's bounded by two functions, and the x-axis, on the x-axis a to b. So the integral, and this is the region right here, over r of the surface dA will be the integral first from h to g, g to h, dy, because those are y-equal functions, and then from a to b, dx. In case 2, we could have something like this, where we have a function here and a function here, and the region's right here. So first we're going to integrate from j to k, and those are x-equal functions, so we're going to do dx first, and then from c to d, those are y's, so that's dy. Okay, and we're going to generalize that even further in this example, where we take any region, and R is bounded by y equal x squared and y equal 2x. So let's graph that. So here's R, that's parabola, and they intersect at at the point 2, 4, because you set them equal. So we're going to go from 0 to 2. So the way we can set this integral up, and our surface is x cubed plus 4y. We're going to go from here to here. 2x is on top, x squared is on the bottom. And those are y's. And then we're going to cut up the x-axis, 0 to 2 dx. Okay, now let's do the integration on that. So first we're going to integrate with respect to y. So x cubed is a constant, so that's just going to be x cubed y. And the integral of 4y is 2y squared. Again, we're doing y. So substituting in 2x for y, we're going to get 2x to the 4th plus 8x squared minus, now substituting x squared, we're going to get x to the 5th plus 2x to the 4th. That's going to be negative x to the 5th plus 8x squared, because those are going to cancel. Then I'm going to integrate that from 0 to 2 dx. And I'm going to get negative 32 thirds plus 64 thirds minus 0 is 32 thirds. Now, if we reverse the order of integration, we should get the same answer. So I'll draw another picture. We're going to go this way first. This is x equals the square root of y, and this is x equal y over 2. So we're going to integrate with respect to x first, and then we're going to integrate along here, 0 to 2, with respect to y. So first, when we integrate with respect to x, we're going to get x to the fourth over 4. Y is a constant, so this is just going to be 4yx from y over 2 to the square root of y. That's going to be y squared over 4 plus 4y to the 3 halves minus y to the fourth over 16 times 4 is 64 plus 2y squared. Okay, so that's going to be minus 7/4 y squared minus y to the fourth over 64 plus 4y to the 3 halves. We're going to integrate that with respect to y. Now notice I don't put it equals here. That's not true. This is just the first integral, then we're going to do the second integral, so they're not equal. Okay, let's see. This is going to be okay. That's going to be, let's see, that's going to be 2 times 7 times 2. So this should be 0 to 4. Okay, sorry. This is the point to 4. The y value is 4. So that should be 0 to 4, 4, 0 to 4, okay. Let me do it this way. That's going to be minus 7 times 4 times 16 over 12 minus 4 times 4 times 4 times 4 times 4, that's 64. 4 to the cubed is 64. Plus 8/5. Square root of 4 is 2. 2 to the 5th is 32. Okay, so we're simplifying that. We're going to get minus okay, we can, that's going to be, use a calculator, 160 over 15. We're going to divide 160 by 5. That's 32 thirds. So we get the same answer if we reverse the order of integration. Okay, let me show you another example of that. Let's say our region here is y equals square root of x, and y equals square root of 3x minus 18. That's what our bounds are going to be. So let's draw that first. And they intersect. This is y equals square root of x. This is y equals square root of 3x minus 18. This is 6, 0, 0, 0. They intersect at 9, 3. We set them equal. X is 9. So 9, 3 is our point of intersection. So if I do it with respect, if I do it vertically with going up and down, we have to split it up because the top function and the bottom function change. From 0 to 6, the top is this function and the bottom is the x-axis. From 6 to 9, we have the function here and the function here being the top and the bottom. So they change. So we'd have to split up the double integral. So we're going to have to go from 0 square root of x, 0 to 6. Then we have to go from 6 to 9. The top function is square root of x. The bottom is square root of 3x minus 18. Now that would be the same as if I went this way. And this time I would go from 0 to 3. The y value is 3. So here I have y squared plus 18 over 3. That's what x is equal to. And here I have x equal to y squared. So I would set up the integral y squared plus 18 over 3. This would be y squared dx. And then the y values would go from 0 to 3 dy. And that will give us the same answer. So you can reverse the order of integration. You just have to be careful and change your limits of integration.